Hope you're able to hear me and see my screen as well. Okay, let's start. Good morning or good afternoon, everyone. Welcome to ASCS webinar on UL1741 SB or CSIP compliance using Kalki middleware. Before we start, I would like to thank you all for taking time from your schedule to attend this webinar. I'm Nirmal Tali. I'm working as a Director of Product Management and Marketing for ASCS and Kalkitech. A few points to keep in mind before we start off. This will be a listen-only webinar. However, to facilitate clearing of your doubts or queries that may arise during the course, please feel free to type in your queries in the question pane of the webinar control panel. You can find it on your webinar GoToWebinar pane. If time permits, we will answer during the session, or else we'll be sharing our response to you on your registered email ID. Welcome once again. So here's the agenda for today's session. So we will talk a little bit on background of UL1741 SB or IEEE 1547 requirements, how ASCS offering can help you in complying with the standard, primarily for OEM standpoint, how the OEM products can be complied with UL1741 SB or IEEE 1547 requirements. We'll also discuss upon what are the integration options provided and what are the detailed product features as well. We can also look into the detailed consultancy and support provided by ASCS to fast track the compliance and certifications for your product. And what are the protocols which would be ideal fit for the compliance at the moment can also be looked at the end of the session. So moving on to give a background. So UL1741 SB is an industry standard for certification of inverter safety, and it includes various safety test requirements in addition to the IEEE 1547.1 conformance testing or type testing. So 1547 standard is basically designed to standardize the behavior of interconnected DER, whether it's a solar inverter or battery storage or fuel cell, during an abnormal grid conditions, and it also ensures the safety and the grid stability. So 1547.1 is the test procedure substandard, which covers type testing as well as the interoperability testing for the DER. The type testing parts covers testing of functional aspects of the DER, like what are the functionalities supported by each DER equipments. That is primarily covered in the functional testing. And interoperability testing ensures the communication or the data exchange from these devices with the utility system will ensure that the exchange mechanism selected will be able to meet the functional and type test requirement for the DER. So interoperability testing as per 1547 just validates the messages are received properly and properly understood by the DER. So interoperability testing is not purely a protocol conformance testing, but actually functional testing, which can be done through a communication interface. So 50% interoperability requires compliance using any of these protocols, which which you can see it over here. That is IEEE 30.5. That is a default protocol which is selected for the communication, and it also allows communication over IEEE 1850, that is the NP3 standard, or a SunSpec Modbus, which can be over serial over Ethernet. And the communication, the standard also specifies that the communication has to be locally compliant. It should not be connected from a external cloud system or external data collection system. Okay. On 1547 or UL1741 SB requirement is primarily for DR devices like a PV inverter or a battery storage controller or a fuel cell controller to exchange the data. It could be information data, monitoring data from the devices, or it could be controls set points set from the utility center, data center. So there should be an exchange mechanism from each the devices with the utility. It can be over any of the protocols mentioned in the 1547 2018 specification. That is 2030.5 SunSpec or the NP3. So how that is met? There are three options. Primarily, first option is a software gateway. It could be a gate software which can goes inside the PV inverter, or could be a controller or fuel cell controller, any type of DR equipments. The software can sit inside the devices and connect with the backend software or controller software and exchange the data over any of these protocols. So that is the option number one. Option number two could be a hardware module, could be OEM module or PCB card, which has an inbuilt software stack, supports in 2030.5 or SunSpec or DNP3. So the hardware module can be integrated with the devices through any of these standard interfaces like TTL, I2C, SPI, or Ethernet. So the second option would be more proper or suitable for devices which has got resource constraints. Existing hardware resource is not enough to run additional software modules, additional software stack, protocol stack. Then a hardware-based approach would be an ideal option. Or else if hardware has got adequate resources like RAM, memory, and CPU, an inbuilt software would be an ideal option. Even if these two options are not possible, the standard also allows for using an external gateway. So external gateway can be connected to the devices through any protocol. The protocol can be proprietary or non-standard, or can be standard interfaces like Modbus or MQTT or anything. Whatever data coming out from the external gateway has to comply with 10.5 or the MP3 of the SunSpec. So here the certification, if you go with the certification has to be for the package, for the included in the gateway and the device. But in the first two options, the certification will be for the end equipment. That could be inverter or battery storage controller or EV charger, whatever it may be. So what are the ASCs offering for complying OEM devices for 1547 or UL1741 SB? So we provides all the three options. The software option we call as KIOE, that's a Kalki IOU software, which is primarily a software which can be a native application, Linux application, which can be deployed on the devices, or it is also available as a container, be a Docker container, or any other container flavors which can be deployed on the their devices. And this software base which runs inside the device can help you to comply with any of the standards. Or maybe if you want to have all the three interfaces available, it can be enabled for all the three interfaces and make your devices comply with the standard. So embedded module, as you can see here, this is a PCB card with a processor and the memory, which has got inbuilt software stack in it. The software stack help you to comply with the 1547.1 interoperability test requirements that is complying to any of these protocols. The hardware can be sit inside their devices, or it can be a retrofit box outside the devices as well, directly connected to the communication port. So if you say internal device, so then you need to have mechanical changes within the box, within the device to accommodate the embedded module. Or if it is a retrofit module, this has to be packaged in the enclosure, and power supply has to be provided to this particular retrofit unit. And it can be an external gateway option as well. So external gateway options, there are different hardwares available depending upon the applications and the number of inverters available. If there are multiple inverters in the side, you can connect multiple inverters to the gateway, and the single gateway can comply to the any of the standard protocol. But as I mentioned earlier, so if it is an external gateway, the certification will be for the packaged option with the gateway plus the devices, not for the individual device. Will not have the full compliance of this standard. So how it is integrated with your hardware or with the device or the smart inverter platform. We'll look at each options in detail one by one. So this is the first option, that is the Kalki Edge software approach. So here you can see this particular box is the smart inverter platform, which is smart inverter or the battery management applications running inside the platform. And Kalki Edge can be one other application which can be deployed inside the inverter platform. The Kalki Edge application can connect with the smart inverter backend over any of these interfaces, like an MQTT. Could be Modbus, it could be SunSpec. It could be SunSpec Modbus, or it could be a standard Modbus as well. It could be an API-based approach, where if inverters provides an APIs, WebSocket APIs or REST APIs, or any other custom APIs, we can have this integrated to the Kalki Edge and exchange data with the Kalki Edge and the smart inverters. And once data is available, the Edge can enable you to comply with any of these protocols. If you want to have all the protocols enabled at the same time, that is also possible. So you can have the MP3 at 10.30.5, SunSpec, all the protocols available in your device. In this case, UL1741 SB boundary will be the inverter in that device or the smart inverter platform. Once we have this, you can achieve different use cases. We can have local exchange with the local software, facility management software, or maybe energy management systems can be done through any of these interfaces, like SunSpec Modbus. MP3 can be used for local exchanges. And for utility integration, you can use it at 30.5 or the MP3 directly with the utility head end. Or if ADMS or SCADA system have that, DERM system have that 30.5 capability, you can actually extend data with the SCADA systems or DERM system onto the 30.5. In addition to that, the data can also be shared with the Kalki Data Hub. This is a centralized device management and identity management software, as well as this can also function as a aggregator service that is with the 2030.5 server and 2030.5 aggregator client. So if you want to share data with a market application, for example, you can directly share the data with the utility. In addition to that, you can share the data with the market application or data hub on 2030.5. And from the data hub, you can share it with an external system over REST APIs or Kafka or whatever the IT interface layer which is required to integrate with the external application. And this will also allow you to exchange the data with the your own cloud, that is your own OEM cloud or inverter management systems or site management software, and also avail this data directly over an internet. So the software, the primary requirement of the software can run on any types of hardware platform. It could be x86, it could be ARM, it could be PowerPC, whatever it may be. Basically, the resource requirement would be to have minimum of 32 MB RAM and 64 MB storage, flash, or maybe storage disk. And operating system can be any flavor of Linux. You can have this cross-compiled and imported into your device with having meeting any of these requirements. And it can be packaged as a TPN package, RPM package, or could be a Docker package as well. So there are various options we can work out depending upon the end device or the inverter platform capability. So this is all about the software-based approach for the 5047 compliance or 7041 SP compliance. Next, we can look at the embedded module-based approach. So the embedded module, so there will be hardware, a small PCB which goes inside the inverter platform, and this module can be integrated with the smart inverter platform through any of the serial or Ethernet interface. Could be a TTL level signals, it could be SPI serial or I2C serial, or it could be an Ethernet based interface as well. So if an inverter has got any of these interfaces, can directly integrate with the module through any of the pins available in the backend. And the software integration and the data exchange integration can be through any of the protocols like a API based approach, standard REST APIs or a WebSocket APIs or MQTT, Modbus, or any custom APIs can be used for exchanging data from the inverter platform with the OEM module or this particular board which you can see here. And this particular hardware has got the stack for 20MP3, 23.5 or SunSpec, which helps you to comply your product for the UL1741 SB or 1547 standard. And all the use cases which you see in the earlier slide can be met. Here, if you can have a local facility EMS or a HES system, you can exchange data with those systems on the MP3, SunSpec, or MQTT, whatever it may be. At the same time, you can also send the data with the utility system on 2030.5, SunSpec or DMP3. So 2030.5, again, it has got different versions or different profiles. We support CSIP, that is the Common Smart Inverter profile, which is defined in the US, as well as there's a profile for the Australia as well. So both profiles are supported as a configuration option in the software. And once data is available as the utility data hub, can be shared, that utility DR has it can be shared with an ADMS, SCADA, or a DEMS system at the backend. Similarly, with this approach also, you can share data with market applications or any other external applications or ISOs through an aggregator platform as well. So there's a Kalki data hub is an aggregator which can help you to integrate aggregate data from multiple sites and provide a single channel connector to the backend or the external applications like an ISO or a market applications. And you can also, this can sit on a independently on a cloud, or you can also sit along with your inverter management system or cloud. Can be integrated with your cloud, and the data from the devices can be connected to the OEM cloud, and that hub can be used to collect the data and push it to the external systems over the REST APIs or the OpenADR or different interfaces as required for the integration. This is the third approach, that is external gateway based approach. You can have select the hardware depending upon the number of inverters in the site. You can have the multiple hardwares and the certifications, the hardwares with multiple certifications as well. So the hardware, the gateways, which you can see over here, you can connect with the DR devices over serial or Ethernet. A serial can be asked to direct link, or could be asked for a 5 DC chain loop, where multiple DIRs can be looped and connected to the DR gateway. And DR gateway helps you to comply with the UL1741 SB certification. So this can enable you to have any of the protocols like DNP3, SunSpec, 23.5, and rest of the story is same. So gateway can exchange data with the utility systems directly out to 30.5. It can also exchange data with an aggregator. So Kalki can also be act as an aggregator, where you can aggregate data from multiple sites and provide either a single 23.5 link to the SCADA to the utility backend system, or it can also aggregate and provide REST APIs or other IT integration options like Kafka or MQTT integration to the external applications like market or ISOs. And this will again enable the OEMs to connect directly with the OEM cloud as well. So the solutions helps in meeting all the requirements, regulatory as well as the device management and monitoring requirements for the utility. So but the software which is which can sit inside the device, or which can be external OEM module, or which can be the external gateway. The software is called Kalki Edge, and it can be integrated with the smart inverter platform through any of these interfaces. So you can have select interface depending upon the capabilities or the existing interface availability in the inverter or in the other device. We can go with an MQTT based integration option. If your inverter supports the MQTT, you can have a MQTT based integration option. I can have our own sync APIs and other options, so we can provide the data exchange to a WebSocket on JSON. We can also exchange data on OPC UA or Modbus interfaces as well. It could be a proprietary model, proprietary registers, whatever the register supports by the smart inverter or OPC model supported by the inverter platform. Can integrate the data from the platform through the OPC UA Modbus, or it can be any custom APIs as well. So using any of these interface, data can be collected by the edge. This edge can sit inside the gateway, inside the other devices. It can be sit in the gateway external to the other device. It can be sit in the gateway internal to the device. So once data is available, the calculators, it has got a generic protocol translation layer or protocol translation engine, which helps in converting these data from the multiple these interfaces to 2030.5 or DNP3 or SunSpec, which is required as per the certification standard. These are the integration option, local integration option from the Kalki software with the device. On security side, the software, the Kalki software comes with three levels of trust chain. Trust chain one is primarily non-installable trust chain, which is the which we call as TC1. TC1 is the trust chain which we are using to sign the firmware, sign the Kalki Edge firmware itself. This is basically to ensure that this firmware cannot be changed by any third party unless the particular firmware is again signed by ASC or Kalkitech. So the firmware which we will be using will be signed by ASC or Kalkitech, and this will it cannot be changed by any third party unless it is signed by ASC Kalkitech. So that this is the trust chain which we are using for securing the software or firmware which is running inside the device. And we have got a trust chain 2, which is primarily device management trust store, which can be which are primarily installable trust store, which can be supplied by a service provider, could be supplied by ASC itself, or it could be supplied by a utility or a customer, like could be a developer who is owning the assets. So PKI can be provided by the different parties, and that PKI can be installed in the device or installed in the Kalki Edge software, and this will enable you for the role-based access control of the device or the firmware, basically to enable the or expose the device management functionalities or administrative functionalities where the user can do the configuration of the software. User can upload the logs, upload the firmware. All the user access can be controlled through trust chain 2. Trust chain 3 is again installable trust chain, which is used for establishing the communication with the utility. So that can be a rule. We can have multiple types of PKIs. It can be Rule 21 PKI infrastructure approved by utility or regulatory, or it could be any other custom PKI as well, is also acceptable by the device. So if you have your own PKI, you can use it to import it to the device, into the software, and that PKI can also be used to connect with the establish the IEEE 30.5 connection or the NP3 connection as well. So these are the 3 levels of PKI infrastructure which is supported by the product. Talking about the security in detail. So the hardware platform, which is the gateway or the embedded module, comes with the different levels of security. All the hardwares are secured ground up, including the OS is hardened, application software, the firewall are enabled in the hardware. And the hardware gateway, the external gateway comes with a TPM, trusted platform module with a secure boot feature inbuilt. And it also have an application sandboxing. This is primarily ensure that the whatever applications which is facing with the network are provisioned with the minimum privileges, so that this cannot be used to enter into the system and do any malfunction of the devices. Again, for malicious software prevention, so as I mentioned in the earlier slide, there's a PKI trust chain mechanism which we have adopted. The trust chain 1, which is non-installable, which is used for signing the firmware or software supplied by ASC or Kalkitech. This is primarily to ensure that the software cannot be uploaded by any or updated by any third party without a proper approval. And each signing can be done with the stages, like a firmware released to the customer can be tagged with the staging or QA or production signed, so that this ensures that this particular firmware, which is tagged for developer testing or maybe QA testing, will not go into the production devices. And we also have the zero trust access control security also built in. We'll look into the zero trust access control security in detail in the coming slides. So these are the layers of this protocols, the features which is supported by all the three options. You can see that the external gateway have got all the supported layers, including TPM, secure boot, hardened Linux, firewall, application sandboxing, firmware signing. These are on the platform level. The application level is data logging features, data management, protocol translation engine are built in as part of the application. So gateway has got support all these layers. In the case of embedded module, apart from the TPM and secure boot, all the other security platform and the application layer features are supported. In case of KOE, that is Kalki Edge software, it is primarily application software, which has got all the functionalities like data logging, data management, protocol translations, etc. And you can also have the other security management like identity management interface, diagnostic and log interfaces, protocol drivers as well. So, and the rest of the platform and the hardware level will be combined by the dev device. So this is a software application which goes inside the inverter or the dev device. So the rest of the interface will be has to be combined by the dev device. And there are different protocol interfaces supported by the Kalki software. So it could be for utility integration 2030.5 is the de facto standard for the DR integration. In addition to that, supports the DNP3, 650, 6.0, 1.01, 1.4, or other protocols as well. For DR integration, it can be 2030.5, SunSpec, Modbus and DNP3. You can also have the OCPP for EV charger integrations or EV charging station integrations, SnapT, TLMS, COSM for meters, backnet, etc. And the stack also, the edge stack also comes with IoT platform integrations through OPC UA, MQTT, Amazon, AWS platform or the Azure platform as well. So these are the protocol capability. So these are the minimum set of protocols supported by the Kalki middleware, and there are other protocols which is listed in this particular link as well. The Kalki middleware or the DR gateway comes with a flexible data mapping option. So if you want to have multiple uplink like a DNP3 and 2030.5, both has to be enabled. It can be done as a configuration option in the Kalki middleware. Yeah, so if you are integrating the inverters through a Modbus, the Modbus data can be collected by the Kalki Edge, and it can be shared with the SCADA system on the DNP3, and same data can also be shared with the 2030.5 for the DER or DERMS integration. And if the integration is through DNP3 or any of the custom APIs, all the data which is collected from the devices can be mapped to DNP3 or 2030.5, depending upon the data profile requirement for the utility. And the stack is also certified by SunSpec for CSIP, that is common smart inverter profile, released by SunSpec for the US. And this has been tested for all the mandatory and optional function set as specified in the 2030.5 CSIP standard. And talking about device management or the software management, software remote management, the Kalki Edge software or the embedded module or the external gateway can be remotely monitored and managed from a cloud-based application called Kalki Data Hub. So you can use this to monitor the communication status. It could be a 2030.5 communication with the utility. It would be communication with the inverter system for southbound communication, could be used for monitoring the other health information from the system. It could be the network signal strength or other alarms which is being picked up on the from the device or from the Kalki software, and can be monitored on a dashboard. I can also used for configuring the notifications like email or SMS or Teams integration. If there's any communication failure or if there's any alarm, system alarms can be notified to a system operator that a specific set of devices or specific device communication link has been failed, so that the system operator can take necessary action on top of that. And this Kalki IOU, the data hub can also be used for remote access, secure remote access of smart inverters. So the remote gateways, Kalki software or the embedded module or external gateway, which is connecting directly to the inverters, can also be used for remote management. If the inverter has to be configured or updated, firmware update has to be done from the configuration port. You can do all these configuration management, troubleshooting aspects remotely from any locations through a virtual port. It could be a virtual serial port or virtual Ethernet port connected to the site through Kalki IOU Edge and Kalki IOU Data Hub. So this provides a secure role-based access control. So it can provide access to specific inverters at the site. Even if it is same site, if there are multiple inverters in the same site, you can provide access to specific inverters to a technician or to an OEM as required. So this is a fully secured zero trust access control mechanism with a role-based access control for remote device management of the end devices or inverters. And once Kalki Data Hub is available, there's an option to integrate with the multiple applications as mentioned earlier. So multiple DAS sites, to be solar, storage, or fuel cell, whatever it may be, can be connected with the OEM cloud on the native interfaces, whatever the native interface is supported by the inverter management software. This data can be exchanged with the data hub through a custom connector or REST API. And once data is available with the data hub, the data can be exchanged with the utility over 2030.5. So data hub can also act as a DER aggregator or a VPP interface as well. So data from multiple sites can be connected through the OEM cloud, and from here you can have a direct interface with the utility system or the 30.5 or DNP3, and same data can be exchanged with the energy market applications through REST APIs or Kafka or other IT integration layer as well. So talking about the consultancy and support, but we provide consultancy and implementation support and testing support for the OEMs. The consultancy, so ASCS have been working on protocols and communications since inception in 1980s. So we have got a bunch of experts who are working on the core domain of communication and the computing systems. So they can help you in or can use our expertise to consult and implement the protocols or implement the interfaces as required for the certification. We can also provide a hands-on session on using the simulators or test tools as a training session. We can also help you in ensuring the compliance with the specification as well. So we also provide the consultancy to the specification standards, and if there is any clarification on the specification standards, that is also something which we provide as an additional consultancy services. And we have a dedicated implementation team which can help you to design or develop the software or hardware for your device, smart inverters or battery controller. So it can help you to customize the integration and interfaces directly with within your system as per your requirement. So there's we also have a review of technical team who does the review of design and ensure that the whatever the mechanism which is adopted is interoperable as per the standard defined. And they can also adopt to the your own development and management process as well. On testing side, we have been getting the conformance test done from your development ecosystem and the certification test bed as well. So we do the pre-certification testing using the Quality Logics tool. We also help you in automating the test environment for your development ecosystem. Also helps you in providing technical support for identifying the root cause of the issues and fixing the issues as required. We also have the technical team to help you in moving the software to the production ecosystem. So once the certification is done, then you decide to move to the production, then there would be a more tighter integration on how the configuration is done by a technician. Could be through a mobile app or could be web browser, which is all pre-built within the inverter or within the devices, and how the existing ecosystem can be used for configuration of these protocols and configuration of these interfaces is also something which we can help in supporting. Moving on, so for helping the testing requirements, we have dedicated test tools as available. So there are two types of test tools: utility system simulation test tools, which is primarily acting as a 2030.5 server, and you can connect your DAD devices with the 2030.5 server and test the interoperability as well as conformance as per the standard. So the test tool, the server utility system simulation test tool, which help you to for the OEM devices or your devices to connect with the test tool and test as per the conformance requirement. There are other version of the tool used for the device simulation. Device simulation can help you in simulating thousands of devices in a single software, and which helps you to simulate multiple devices and do the scalability testing and data exchange testing as well. So both the device simulation and the utility system simulation are done using the ASC2000 test tool. So the ASC2000 is our legacy protocol test tool, and we have added the capability for the 2030.5 as well. So it already have the NP3 test set capability. 2030.5 is a recent addition to the ASC2000 test tools. Talking about the protocols to be considered for the interoperability testing or certification testing, these are all our views. For you would prefer, you need to consider specific factors like utility preference. What is the specific utilities utilities preference where you are planning to sell the product? For example, the utilities in California is going ahead with 30.5 using CC profile. Similarly, other 30 plus utilities are coming or working on specifying CC as in the interconnection handbook as well. So we believe that 2030.5 would be a more appropriate utility preferred protocol for the certification testing. Another aspect to look forward is a regulatory preference. So the regulatory preference as well for 30.5, what we see the California Rule 21, Hawaii Rule 14, or Australia has also come up with its own flavor of CSIP Australia. which is again based upon 2030.5 standard. So multiple regulatory regulators are also preferring 2030.5 for the direct integration with the utility system or the distribution system operator integration. Another factors which we need to look forward is a deployment preference. 2030.5 is best suited for the internet-based applications. Like you could sit behind the meter with the enhanced security. So 2030.5 provides much reliable communication for a low power lossy networks as well. So that would be a preference for as far as deployment is concerned. SunSpec Modbus can also be used if it is a local gateway, and since it is a Modbus and Modbus is a request response protocol, for local communication, local integrations, SunSpec Modbus would be a more preferred option than for a utility interconnection. As far as technical preference is concerned, there also the 2030.5 is the preferred option as it supports multiple advanced use cases and managing devices in a group. You can issue commands to multiple devices in a group at a single time. You can also, the protocol is also firewall friendly in terms the communication is always initiated from the field towards the server. So since the client is sitting in their devices, they can go outbound from the field towards the server sitting in the utility or DSO premises. So since because it's outbound, it's a firewall friendly protocol, unlike a DNP3 or maybe a SunSpec Modbus. And also the security is also built in as part of the protocol using the PKI infrastructure. So with this, I would like to conclude my session. Go to the Q&A. Okay, I have got 2 questions. Interface with the IEC 61850. Yes, so we have the IEC 618 interface as well in the Kalki edge, both the client and server. But as far as UL1741 is concerned, that will not be a mandatory requirement for getting certification. But if there's any specific market which requires 618, it can be enabled using a configuration option that is readily available. Another question is what will be the estimated time and cost of integration for each options. So it depends upon the each option you go for and what are the interfaces available. So if it is a software gateway, that is option number 1, and sitting inside the devices, the only time would be required for would be to deploy the software in the gateway in their device. And integrating with their device backend. So if their device backend has supports any standard interface like MQTT or Modbus, let's say the integration and testing approach, testing would take around 4 to 5 weeks. If it is a hardware-based integration, especially OEM modules, embedded modules, then it would take more time, especially it involves a mechanical change and hardware change, both at the inverter and the mechanical side of the inverter as well. So let's say the hardware embedded module would be require larger time in terms of 14 to 15 weeks at least. And for the external gateway, it will be straightforward, but the drawback of the external gateway is that you can get the certification with the external gateway packaged option. Not if we go with the internal embedded module or the software gateway, the certification will be for the inverter or the device. What is the estimated timeline for UL1741 SB certification? So typically it will take around 10 to 12 weeks for you to get your product certified from an NRTL labs. So it also depends upon the slot availability as well. So if the NRTL, you need to have the slot booked prior, and if you have the booking, if you start the testing, it will take around 10 to 12 weeks to complete this certification testing and the compliance certification issuing. So with this, yeah, there's one more question. So maybe I'll connect with the person directly. Couldn't understand the entire question right now. We'll have a separate detailed discussion on that. So with this, I would like to conclude my webinar. And if there is any specific questions you would like to send across, please share it with marketing@kalkitech.com. We'll be happy to respond you within one working day. Thank you all.